Okay, glider RC is up.
Look for engine start. Engine start.
I'm an airplane geek. I grew up reading about NACA and NASA and Edwards Air Force Base and Rogers Dry Lake. I think it's beautiful. I love the arid, dry landscape. I love the flyable weather 300 plus days a year.
How's the tow line look? Come on back, Derek. I'm having a hard time seeing it.
I have no degree. I learned my craft from on-the-job training and self-education. My name is Red Jensen, and I'm the chief pilot at the Armstrong Flight Research Center for Small UAS. I work in the model lab day-to-day using subscale aircraft, and we use those for a variety of reasons to test things like new technology, which could be hardware or software, or even a completely new vehicle.
Coming through, guys. Where the phone blocks?
This morning is something you don't get to see too often. This is the first flight of a brand new airplane. So that also means it's a lot more dangerous than it normally would be. Especially for the first several flights. Be on your feet, not sitting down. Probably between the cars is a great place until we prove that it's airworthy and everything's going to go fine.
Okay, clear out. 3, 2, 1, release. Better. Oh. That's a little weird. Heads up, guys.
Essentially what my job entails is making sure that the fleet of subscale aircraft we have here at Armstrong are capable of flight, are safe, and are ready to support the center for the various needs.
We're not supposed to break above 30 knots for some structural issues.
Right.
So the trick is to touch down, roll the throttle.
Each one of the aircraft supports a variety of different programs. Any one program at any time could have a certain set of milestones they need to hit, and we need to make sure that can happen. So we support the build-up, the integration, and the execution of the actual flights. I'm part fabricator, I'm part engineer, I'm part integrator, and I'm flight crew. So I have to manage all those elements sort of all in one. Almost use that, huh? Not quite.
Yeah, except we're gonna have to angle it.
A typical day is you come in, and I usually make a list of the things that we want to accomplish during the week and then also daily. On non-fly days, we have ongoing projects, things that need maintenance.
Basically case 5, yeah. Case 5, yeah. All right, so is that our max design intent? Is that what that is now?
This is
I work on drawings for layups and engineering calculations for load. We are setting up mounting components, testing them, getting ready to fly. Often I have to make a one-off part. I also have the capability to 3D print parts in-house, which has been a blessing because it allows me to design something in the morning, build it in the afternoon, and install it in the evening. It's really that quick. Not have an Alpha Beta Pro. Okay. Installed.
The Alpha Beta van is not installed, or is it?
Alpha Beta 2 CPT. Flight day usually starts 2 days before. I don't like to rush. I want to make sure that we don't miss anything, because on a flight day, if you do miss something, well then that's just making everybody wait, and that's not cool. If the system hasn't flown in a while, or it's got a new component in it, we do a CST, which is a combined systems test, where we turn everything on, just like in a flight environment, including starting the engine if applicable, run it, and do all these ground tests, just like we were going to go fly, and make sure that everything works and plays nice together. That way when we get out on the lake bed to fly, there's no surprises. So that's done, let's say on a Monday, we finish our CST. Tuesday is prep and loading day, where we'll maintenance all the batteries, make sure the generator has gas in it, make all the arrangements for frequencies and whatever else we might need on the lake bed, load up the vehicles and be prepared for the next day. The third day Flight day usually starts at 6 a.m. in the model lab. I like to get there again a little bit early, go over my checklist, make sure I have everything loaded, everything's prepped and ready to go. I typically like to be airborne by 9 for weather reasons, and that gives us the best chance to fly as much as we need throughout the day. It's airborne. A little bit of right aileron trim, a little up elevator trim. Here comes a flap check. 1 notch, no pitch change, 2 notches. Very nice, no pitch change, flaps off.
Okay, here comes first stalls clean. 28. Keep them coming, crew. Approach flaps. Alright, I'm gonna start setting up for an approach. Alright.
And we're down. The largest project that we're working on right now is the TGALS concept, which is the towed glider air launch to orbit concept, where we use a glider to carry a rocket launch vehicle up to an altitude, release that rocket, and then it'll head on into space. The idea is cheaper cost per pound launches to orbit. So by air launching the launch vehicle, we gain somewhere on the order of 50% performance increase to get the same amount of payload into orbit. We have built and are flying a quarter-scale, roughly, model that eventually could turn into a 100-foot wingspan, full-scale X-plane type program. Another program that we've been working on is called Prandtl. Prandtl is looking at a new way to design a wing to reduce induced drag. And induced drag is a byproduct of creating lift. So when you create lift, you create drag. This particular wing uses twist to reduce that drag at the wingtips and manipulate that for control.
3, 2, 1, release.
Has huge long-range potential benefits. Things like airliners, where you see the winglet on every airliner that increases efficiency. Prandtl looks to do much of the same thing, but even on a bigger scale. Flight days, they can be an hour, they can be 6 hours, just depends on what we're doing. We'll bring everything back to the lab, unload what we need to unload, and then gather any data that's necessary and send that out to the proper folks. I don't do too much of the data analyzing, but I definitely facilitate the downloading, and we certainly look at the data, but that's left to other folks on their respective projects to analyze the data. My job is to gather the data, make sure the data is good, and then disseminate it. I love to design. I design a lot of my own aircraft, and you just simply can't do that easily in the manned world. Timeline, cost, risk, all those things play a factor. With subscale aircraft, you can do almost anything you want without much risk, and you can realize those gains very quickly. Being that we're not putting out a product, we don't have a product at the end of the day that we have to sell, it gives us a lot more latitude to research things that maybe a for-profit company wouldn't bother to research. You know, the winglet may not have come around if it hadn't have been for NASA. Some guy looking for a few percent advantage looked into it and figured it out. Dale Reed was a pioneer of using subscale aircraft, and he was sort of looked as a sort of a crackpot around here. He got the idea of a cone shape as a reentry type vehicle, cut it in half into the half cone, which is the classic lifting body shape that we know now, and those early trials led directly to the space shuttle. So we look into sometimes the minutia of how and why things work that doesn't necessarily make sense for a for-profit company. Everything that we do benefits the public. Nothing is held back. Everything is published and available for anyone to use. NASA, it's a fantastic environment to work in. It's just being a part of an R&D environment and part of something that maybe someday somebody else might remember that was something cool. And I can say, oh, you know, my grandkids, oh yeah, I worked on that. That'd be pretty cool. I would probably be unhappy sitting behind a desk somewhere if I wasn't flying airplanes. I really enjoy working here a lot.